In the previous video, we looked at how to write numbers in scientific notation. And now that we know how to write numbers in scientific notation, we're going to do operations with numbers in scientific notation. We're going to use the 4 operations that we normally use: multiply, divide, add, and subtract. In this video, we're just going to focus on multiplying and dividing, and we'll do a separate video for adding and subtracting. Okay, multiplying and dividing are, in my opinion, the 2 easier operations. And what makes them easy is because we don't have to have the same power of 10. The exponent doesn't have to be the same when we're multiplying or dividing. When we're adding or subtracting, the exponent has to be the same, and we'll see that in the next video. Okay, so for both of these operations, there's 3 steps. We'll focus on multiplying first, and then we'll move over here to dividing in just a second. So step 1 is multiply the base numbers. So remember, our base numbers are the numbers that are to the left of the times symbol. Okay, so 3.42 and 4.67 in our example 1. Okay, then we're going to add the exponents to get our power of 10. Now, if you think back to our first video, the first topic we learned in 8th grade math are exponent rules, or laws of exponents. And one of our rules is we refer to as MADS. So when we're multiplying, we add, and when we divide, we subtract. That's where MADS comes from, M-A-D-S. Okay, so here we're multiplying exponents that have the same base number of 10. So we can add the exponents. In just a second, we're going to divide numbers that have the same base number, so we can subtract the exponents. Okay, so our exponent rules are coming back into play. And then lastly, we have to make sure it's in proper scientific notation. And so in our previous video, we talked about what that looks like. Remember, we have to have a base number that is at least 1, but less than 10. So we might have to move the decimal a little bit. And we have another acronym for that. I call it LARS. So LARS stands for left, add, right, subtract. Okay, so if I move my decimal to the left, I have to add to my exponent the same number of times I moved my decimal. So if I move my decimal once to the right, I have to subtract 1 from my exponent. So we'll see examples of that in just a second. Okay, so example 1, we have 3.42 times 10 to the 5th multiplied by 4.67 times 10 to the 9th. So step 1 says multiply the base numbers. We can use a calculator for this because we're not really testing our ability to multiply decimals here. We're trying to multiply numbers in scientific notation. So we go 3.42 times 4.67, and that gives us, so let me write that step down, 3.42 times 4.67, and that equaled 15.9714. Okay, we'll leave that there for now. Next step is add the exponents to get our power of 10. Okay, so let me write that here. So that'd be like 10 to the 5th times 10 to the 9th. Okay, so I add my exponents and I get 10 to the 14th power. Okay, so now I can combine those. So I get 15.9714 times 10 to the 14th. And that could be my final answer if it is in proper scientific notation, but it is not, since we have 15 here and that number has to be less than 10. So we have to move this decimal once, and it has to move to the left. So we think about LARS, if we go to the left, we have to add 1 to our exponent. Okay, so this is going to be a final answer of 1.59714 times 10 to the 15th. That's our final answer. Okay. Example 2 looks a little bit different, and so we're going to treat it a little bit differently. This is kind of like when we have our power product exponent rule. So it's not really the distributive property, but we're kind of going to give this -6 exponent to both the base number and the power of 10. Okay, so the first step is multiply the base numbers. Well, in this case, we're going to multiply the base number by itself -6 times. That doesn't really make sense. What we're going to do is it's going to be 6.3 to the -6th power. Okay, and we can type that on our calculator like this, 6.3, and this is the caret symbol. Remember, caret to decimal from our last video. And then we can type -6. Okay, and that gives us 0.000015994. So a really, really small number because our exponent was negative. All right, and now we have 10 to the 5th raised to the negative 6th power. Okay, and so that's power product. So we know we keep the base and we just multiply the exponents. So 5 times negative 6 is negative 30. Okay, so now I can combine those. So I get 0.000015994 times 10 to the negative 30th. Okay, check to see if it's in proper scientific notation, and it is not. So I have to move my decimal, and this time I'm going to the right, and I've got to move it 1, 2, 3, 4, 5 times. Because remember, I want my decimal to be after the first digit that's not 0. Okay, so this becomes 1.5994 times 10, and I went to the right 5 times. So right says I subtract. So I gotta be careful here with my negative. So I have negative 30 minus 5. So I'm getting more negative. So it's gonna be to the negative 35th power. So my final answer would be 1.5994 times 10 to the negative 35th. And that's how we multiply numbers using scientific notation. Okay, now let's look at how to divide numbers in scientific notation. So the same 3 steps, except for instead of multiply and add, we divide and subtract. Okay, so all we do is divide the base numbers, then we subtract the exponents to get our power of 10, and then once again we got to make sure it's in proper scientific notation. Okay, so example 1, pretty easy. 8 divided by 2. We know that's 4. Times 10. Now I got to figure out my power of 10. I'm going to subtract the exponent, so I have to do negative 3 minus negative 2. Okay, so negative 3 minus negative 2, subtracting a negative is like adding a positive. Okay, so that's negative 3 plus 2, which gives us negative 1. So our final answer is 4 times 10 to the negative 1st. It's already in proper scientific notation because my base number of 4 is at least 1 and less than 10. Okay, example 2. Divide the base numbers. So my calculator can do 1.4 divided by 1.8. And I get 0.7 repeating. So I could just write 0.78 maybe. Okay, so I'm rounding a little bit. Okay, and then I have times 10. And now I have negative 4 minus 4. Okay, so I'm subtracting, so I'm getting smaller or more negative, so I'm going to have negative 8 as my power there. So negative 4 minus 4 would be negative 8. But not in proper scientific notation because 0.78 is less than 1, so I got to move my decimal once to the right. So I get 7.8, roughly, I rounded that, maybe 7.7777 times 10. And I went right 1, so I subtract. Negative 8 minus 1 would be negative 9. And that'd be my final answer. And that's how you multiply and divide numbers in scientific notation.